So let's dive right in. Welcome to our breakdown of what is literally a monumental shift in the industry right now. We're moving away from those basic, everyday chatbots and stepping into the world of truly autonomous, multi-agent AI systems. And today, we're looking at the engine powering this exact shift, NVIDIA's new Nemotron 3 family. Just think about this for a second. How are enterprise AI agents actually going to function in the real world in 2026? Because right now, traditional language models are hitting a massive brick wall. They struggle with speed, they don't have reliable memory, they can't effectively use external tools, and the compute cost is just off the charts. The core of the problem is pretty clear. If you want a true autonomous agent, it needs to continuously ingest and make sense of complex documents, endless video feeds, and raw audio. To act as a universal brain and planner, a fragmented approach just doesn't cut it. We needed a completely new model architecture. Here's our roadmap for today. First, the era of autonomous agents. Second, the Nemotron 3 hybrid architecture. Third, the model lineup and multimodality. Fourth, hardware innovations. Fifth, competitor comparisons. And finally, the enterprise open license. We're unpacking everything from the deep tech under the hood to what this actually means for businesses. Section 1. The era of autonomous agents. Let's start with the first piece of the puzzle here. Why did the industry so desperately need the Nemotron 3 family to kickstart this era of true autonomy? What's really fascinating here is this hybrid superpower concept. Think of the Mamba 2 layers as this incredibly efficient, linear, long-term memory. Then you have the traditional transformer attention layers acting as a laser-sharp focus for precise retrieval. Add in the mixture of experts, or MOE, and you've got a specialized workforce where only the right experts wake up for each specific task. Moving to Section 2, the Nemotron 3 hybrid architecture. Let's actually visualize how this hybrid engine is put together under the hood. The way this is built is brilliant. The Mamba 2 layers handle the heavy lifting, effortlessly processing massive sequences of data. Meanwhile, the selective self-attention layers are strategically placed like global anchors. They keep the model grounded and ensure precise routing, so the system doesn't just drown in its own massive context. Section 3, model lineup and multimodality. So, how does this architecture scale up? NVIDIA dropped 3 distinct tiers of the Nemotron 3 family. The absolute game changer here is the sheer efficiency. Thanks to the sparse MOE design, the Nano model is 30 billion parameters in total, but only activates 3 billion at a time. It's lightning fast and perfect for edge devices or sub-agents. Then you have the Super model at 120 billion parameters, which is your highly accurate flagship for multi-agent teamwork. And finally, Ultra, a 550 billion parameter beast designed for deep research and planning on data center clusters. But you have to see the Nano Omni variant. Instead of that old, clunky pipeline where you duct tape different models together, Nano Omni natively understands video, speech, images, and text in one single unified reasoning loop. Zero context lost in translation. Section 4. Hardware innovations. Let's see how all of this translates into unprecedented speed through some really radical hardware-aware engineering. When you compare the engineering of standard architectures to the larger super and ultra models, latent MOE totally stands out. It actually compresses the tokens before they even reach the experts. What does that mean? The model can consult 4 times as many specialists for the exact same amount of compute power. It's wild. Now throw multi-token prediction, or MTP, into the mix. This predicts multiple future tokens in one go, kind of like built-in speculative decoding. It results in a massive speed boost when generating complex code or running long agent workflows. Plus, they're natively trained in this super efficient 4-bit format, built specifically for the new Blackwell chips. The actual results? The Nano Omni delivers up to 9.2 times higher throughput for video tasks compared to other open-source multimodal models, and the super version is running 5 times faster than the previous generation. The numbers are just staggering. But what does a native 1 million token context window actually mean for you? It means you can literally drop an entire 100-page legal contract, a massive codebase, or an entire video archive directly into your agent's brain. No chunking, no fragmentation. It sees the whole picture seamlessly. Section 5. Competitor comparison. Let's take off the rose-colored glasses for a second and look at the hard benchmark numbers and the limitations.
The data shows Nemotron 3's Super holding its ground, matching GPT-OSS 120B in logic tests. But it completely smokes Qwen 3.5, achieving up to 7.5 times higher throughput. Though to be fair, Qwen leans heavily into voice. Now sure, models like GLM 5.1 might beat Nemotron in pure coding benchmarks, but Nemotron's real superpower isn't just writing code. It's agentic multimodality and flying through massive video archives.
However, we have to talk about the hardware reality. You can't just spin up the super version on your laptop. It requires serious iron, like 8 H100 GPUs or a cluster of RTX 4090s if you heavily quantize it. Compare that to Gemini Nano, which runs on phones but is completely closed source and lacks native video. Or Xiaomi's Mimo V2.5 Pro, which is incredible but needs a whole data center. Also, Nemotron has some early bugs. The multimodal GGUF versions currently crash in a llama, and there are known generation errors if you're running the newest CUDA versions. Finally, Section 6, the Enterprise Open License. Let's talk about why this release fundamentally shifts the business landscape and proves NVIDIA isn't just a hardware company anymore.
Their new open model license is a massive breath of fresh air. They've completely stripped out those terrifying rug pull clauses and removed the guardrail termination restrictions. For corporate developers, this basically decriminalizes the model. You can build and scale with total confidence.
And they aren't just giving you the weights, datasets, and recipes. By pairing this with secure, local microservices like NeMo Skla and NVIDIA NIM, they're solving the absolute biggest headache in enterprise AI, data privacy. Your proprietary code, financial data, and video feeds stay completely on-premise in a sandboxed environment.
Which leaves us with one incredibly exciting question. We now have a fully open, million-token multimodal engine where the barriers of throughput, memory, and corporate licensing have been completely smashed. So, how are you going to build and deploy your first true autonomous AI agent?